Here we discuss about some electronic arrangement of few elements on the basis of Bohr-Bury scheme. For it, consider helium He, whose atomic number is 2, and in it there is 2 electrons, and it remains in first orbit. Now for Ne, neon, its atomic number is 10 and electrons is 10. First orbit contains 2 electrons and second orbit contains 8 electrons. Now for argon Ar, its atomic number is 18 and electron is number of electrons is 18. First orbit contains 2 electrons, second 2 electrons, and third orbit contains 8 electrons. Similarly for Ba, its atomic barium, its atomic number is 56 and number of electrons is 56. First orbit contains 2 electrons, second orbit 8 electrons, third orbit 8 electrons, and fourth orbit 18 electrons, and fifth orbit 8 electrons, and sixth orbit 2 electrons. Now consider Hg, whose atomic number is at 80. It has 80 electrons. So first orbit contains 2 electrons, second orbit 8 electrons, third orbit 18 electrons, fourth orbit 18 electrons, fifth orbit 18 electrons, and sixth orbit 2 electrons. Again we consider Rn. Its atomic number is 86 and number of electrons is 86. First orbit contains 2 electrons, second 8 electrons, third 18 electrons, fourth 18 electrons, fifth 18 electrons, and sixth 8 electrons. Now we will discuss about the Somerfield extension over Bohr's theory. Although Bohr's theory accounted for the position of the lines in the optical spectrum of hydrogen, it did not account for the splitting of these lines into groups of finer lines when spectroscopes of higher resolving power were applied. To account for such a structure, Somerfield modified the Bohr's theory to include elliptical electron orbit as well as circular. According to Somerfield, each orbit except the first is made of suborbits which may be circular or elliptical. Second, the various suborbits of an orbit have very slightly different energy. The energy of suborbits are also quantized. He introduced subsidiary quantum number k, so that principal quantum number divided by subsidiary quantum number equals to n by k, equals to length of major axis of suborbit divided by length of minor axis of same orbit.